Here we are with functions and their inverses 1.3. Alright, so now these first ones look a lot more difficult than some of them really are. Okay? And the idea is with these rules of exponents. And the thing is, you've got to remember that there's the base, that's the number on the bottom, there's the exponent, what it's raised to. Okay? So if I have two numbers like number 1 where the base is the same, well then I know if the bases are the same and there's nothing else in that equation, I know that those exponents can be set equal to each other. So I can start out by saying x plus 1 equals 2x minus 3. Because if I have 5 on the bottom and they're equal to each other, I know that whatever the exponents are, they have to be the same. So that's kind of the trick, the rule that we're thinking about right here. And then we're just solving these equations. Now remember, to solve these equations, you got to get the x's on the same side. And when we take it across the equal sign, you've got to do the opposite. So this is a positive 1x. I subtract a 1x from both sides. 2 minus 1 is just x. And we add 3 to the other side. So those cancel. 1 plus 3 is 4. So 4 equals x. Okay, number 2, same idea. Same base, so we take their exponents and we set them equal. So 3x minus 2 equals negative 2x plus 8. So I'm going to add the 2x to both sides. That would cancel that, leaving me with 8. 3 plus 2 would give us 5x minus 2. Add 2 to both sides. We get 5x equals, that cancels, that becomes 10. Divide by 5, x equals 2. If you need to, you can double check that by plugging the 2 in. 3 times 2 is 6, minus 2 is 4, so it's 7 to the 4th. Negative 2 times 2 would give us negative 4, plus 8 would give us 7 to the 4th. Okay? So that's all we do now. When we look at 3, 4, and 5, now we see that we have different bases, don't we? Okay, now here's where it gets a little trickier. So you look at those two bases, 4 and 2. Can 4 become some sort of exponent with a base 2? Well, yeah, 2 squared is 4. So kind of what we can do on this side is we can change its base by saying, okay, 4 is really, didn't want to write the 4. 4 is really 2 squared times to the 3x. And remember, one of our exponential rules is that whenever you raise a power to a power, you multiply. So that's really 2 to the 6x equals 2 to the 2x minus 8. Now we can solve. So sometimes you have to adjust those exponents a little bit. But that's alright, you can do that. Not a big deal. Okay, so then we go 6x equals 2x minus 8. Subtract 2x to get it over with the 6x. So we have x is on the opposite side of the numbers. Then divide by 4, and x equals negative 2. Alright. So, number 4. Now 3 and 9. Isn't 9 really 3 squared? So then this 2 we distribute to that side and we get 3 to the 4x minus 6 equals 3 to the 5x minus 4. Now we got the same basis, so we set our exponents equal. I'm going to subtract 4x. Those cancel. 5 minus 4x is just x, or 1x, same thing. Add 4. We get x equals negative 2 again. Okay. Okay? Alright, number 5. Okay, now 8's a little trickier. So if we broke it up, because we need to figure out 2's, 8 would be 2 times 4, and 4 would be 2 times 2. So we have 3 2's, right? So that would be 2 to the third to the x plus 1 equals 2 to the 2x plus 3. 3 goes into x, or not into, 3 times x, 3 times 1. So we get 2 to the 3x plus 3 equals 2 to the 2x plus 3. Set those equal to each other. We get what? 3x plus 3 equals 2x plus 3. Subtract 2x. End up with x minus 3 equals 0. Alright, so now hopefully you guys are trying out these problems before and using this video to help, okay, not to do it for you, because then you won't be learning as much if you try it. Now 6 and 7 have those fractions, okay, but remember we have those negative exponents, and a negative exponent makes it a fraction. So what I'm going to do is I'm going to change this to 5x equals 125 to the negative 1, because that's 1 over 125 is 125 to the negative 1. Then I'm going to say, okay, 125. How can I break that down? Well, 5 and 25, and that's 5 and 5. So I've got 5 cubed, which times by negative 1, so it's 5 to the x equals 5 to the negative 3. So x equals negative 3. Trick to that one was just figuring out that whole negative stuff. Same with number 7. 81 to the negative 1. 3 to the x plus 1. Then we break down 81. 9 and 9, right? So that's 3 and 3 and 3 and 3. So 3 to the 4th. So 3x plus 1 equals 3 to the 4th. So x plus 1 equals 4. Subtract the 1. X equals 3. Alright, so there's those ones. Hopefully that was kind of a review. But if not, there's some new stuff to remember about exponents. Okay, now the set here. It tells us what a logarithm is. Okay? That's one of those parent functions we talked about on that frame. We did one. So it says for all positive numbers a where a does not equal 1 and all positive numbers x, this logarithm in this setup means the same as this. Okay? We can move them back and forth. Okay? The base of the exponent a becomes what we call the base of the log. What it's equal to is inside the log, and then the exponent is what the log is equal to. So wait, why is it important that the definition of logarithm states that the base of the logarithm does not equal 1? Because if we look at the exponent, if a were 1, we'd have x equals 1 to the whatever power. Our answer is always going to be 1. So it doesn't really work, because 1 to the 10th, 1 to the 50th, 1 to the 2nd, it all is 1. Okay, so that's the reasoning behind 8. A exponent with base of 1 is not good. Okay, it doesn't give you anything. Okay, why is it important that the definition states that the base of the logarithm is positive? Well, once again, think about that a. Why is it necessary that the definition states that x in the expression log a of x is positive? Think about if you raise to a power, can you get that negative? Well, what would that mean if you were getting a negative? Okay, so think about that. I want you guys thinking about those rest of those. Okay, now all it's wanting you to do on these ones is just change it from exponential to logarithmic. So it's actually really simple. You use this as your guide. So basically, y equals log base a of x, and that translates to x equals a to the y. Okay, so you just rearrange the pieces. The x, so the one equal to it, is inside there. So we'd go, and the y jumps there, and the a says a. So the exponent, we take the exponent 4, and we say equals log, and in our base, 5. You kind of do it as a subscript, so it's kind of brought down and teeny weensy, and then x is 625. So that's all you have to do. Okay, so 13 negative 3 equals log base 1/2 of 8. Okay, 12, 14, same process. Okay, 15 negative 2 equals log base 4 of 1/16. Okay, that's all you're doing. Number 16, e to the 7th equals e to the 7th. So 7 equals log base e. And actually, whenever you have the log base e, that's called a natural log. So you could just write ln. So you could write it in two ways, of e to the 7th of e to the 7th. Okay. 17 a to the y equals x log a. Okay, I'm not sure what 17 is wanting you to do, because that's basically this. So, and they wrote it for you already. Alright. So 18, compare the exponential form of an equation to the logarithmic form of an equation. What part of the exponential equation is the answer to the logarithmic equation? So the answer, typically would be that. Where do you see that over here? That's what it's asking you to look at. So look at all those answers, see that pattern, and come up with something. Alright, so now, evaluating functions. Okay, probably been a while since we've done this. Remember, that's just how we write functions. All of those stand for the outputs, okay, the answers, the results. And we are dealing with a bunch of different types. So let's start taking a look. So f of a, so I take this function, replace all the x's with a, and simplify if I can. I can't, so I'm good. Same with 20. Replace all of x with b squared, and we're good. For 21, replace all x's with a plus b. Now on this one, I could leave it that way, or I could distribute and end up with f of a plus b equals negative 2a minus 2b. You should probably simplify it like that. Now, if you look at 22, it's got a function inside, okay? That's all right too. So what we're going to do is we're going to take f of x, but everywhere there's that x, we're replacing it with all of that. So I'd go f of g of x, I just leave it like that, equals negative 2, but I don't write g of x, I actually write what the function is, which is 2x plus 5. Then we distribute negative 4x minus 10. Okay? So, now we do the same type of stuff for g. Okay, 23, g of x, we change it to g of a. G of b squared, we change the x to b squared. a plus b. We change it to a plus b, and then we simplify. So distribute, so 2a plus 2b plus 5. So that's all there is to it on those parts. Now the tough one is doing 26, right? So this time we're taking h of x as our base. And inside of all the x's, so 1, 2, and I guess technically 3, we're replacing it with f of x. And that's f of x. So now, instead of x squared, I go negative 2x squared plus 3 times negative 2x minus 10. Now we can simplify. This negative 10 stays negative 10. 3 times negative 2, negative 6x. This 2, remember, we can distribute when we're multiplying inside it. So negative 2 squared is 4 x squared. Okay. Alright, last page. Let's take a look at these last ones. So h of a, so we go replace all the x's with a's. Not so bad. For 28, replace all the x's with b squared and then simplify. So h of b squared equals b squared squared, which 2 times 2 would give us b to the 4th, plus 3b squared minus 10. For 29, h of a plus b equals a plus b squared plus 3 times a plus b minus 10. Now this one we can simplify quite a bit. And remember that that's really like a plus b times a plus b. So if you remember FOIL or double distribution, we'd go a times a, and get a squared, plus a times b, ab, plus b times a, plus b squared, plus 3a, plus 3b, minus 10. Okay? Now, ab and ba are the same thing, so we simplify it further and go a squared plus 2ab plus b squared plus 3a plus 3b minus 10. And there is h of a plus b. So kind of long, but still fairly simple. Okay, now the last one. We're putting g of x, the whole function, inside the x's for h. So h of g of x equals 2x plus 5 squared plus 3 times 2x plus 5 minus 10. So we have to do some simplifying here. Let's kind of think of it in two different sections for now. 3 times 2x would be 6x, 3 times 5 would be positive 15 minus 10 would get us 6x plus 5, because 15 minus 10 is 5. This side we'd have 2x plus 5 times 2x plus 5. So 2x times 2x would give us 4x squared. 2x times 5, 10x. 5 times 2x, 10x. 5 times 5, 25, plus that. So now we combine all like terms. No other squared, so 4x squared. This all equals h of g of x plus 10x plus 10x plus 6x would be 26x plus 25 plus 5 would be 30. And there is our answer. Alright, there we go, guys. We got it down. We should be good to go on this.